Assalamu alaikum to everyone. So we will continue from where we left in our previous lecture. That is the block diagram of an HPLC system, which consists of the different components. So in a block diagram, we have a solvent delivery system, which consists of a solvent reservoir. We have a pump that helps to pressure the solvent through the column under pressure. Then we have an injector that is used for the injection of the sample into the stream of an mobile phase. You have a column that is used for the separation, that is the heart of the HPLC system. Then you have a detector on which there is a detection of the samples. It is followed by a data acquisition or the data processor on which due to the analysis, and then it is followed by a wastewater. So we have basically the components. That is a mobile phase delivery system. As I told you, it consists of a solvent reservoir, pumps. Then there's a sample injection system that is used to introduce the sample into the solvent loop. It may be manual or automatic. So we will learn what is manual and what is automatic. Column packing material should be, that is a column, and then its packing material may be different depending upon, again, the type mode of operation you are using, whether you are using normal phase chromatography, or you are using the reverse phase chromatography, or you are using the ion exchange chromatography, or you are using the size exclusion chromatography. So the packing material will vary depending upon the type of the separation you are doing. Now the detectors may be, again, it may be of different types. It may be of UV detector, or it may be FID detector. It may be any other detector depending, again, upon the type of the sample you are going to analyze. Data acquisition of the readout device. The role of the data acquisition and readout device is to analyze the data, interpret the data, get the information about the results out of the results, and then do the analysis that is required. So first one is the solvent reservoir. The solvent reservoir is the reservoir of a solvent that is placed normally on the top of the HPLC column somewhere here. So you have the different types of the glass bottles in which we can place different types of the solvents at a single time. So you have the 4 channels, so you can run the 4 different samples, 4 different solvents at a particular instant of time, or the mixture of these, or they can run in an isocratic mode. They can run in a gradient mode. We will learn what is isocratic and what is gradient. So you have the 4 different channels, so 4 different solvents can be used. Similarly, in automatic machine, again, you have the 4 different channels through which the 4 different solvents can be used. So solvent reservoir is at the top of an HPLC column, and it is the reservoir of a solvent which is used for the separation of the components or the mixture of the components. So the solvent reservoir contains the mobile phase and are present in a glass containers. In HPLC, the mobile phase or a solvent is a mixture of polar and non-polar components, and depending upon the composition of the sample, the polar and non-polar solvents can be varied. So this is what I am saying. So you can vary your solvent. For example, you are using methanol and water for the separation of the polar components. So depending upon the polarity of the samples, you can vary the concentration of the methanol. You can increase the concentration of the methanol, or you can increase the concentration of the water in a programmed manner, and then it helps in a easy separation of the polar compounds. So again, it depends upon the type of the molecule or the type of the mixture you are using to analyze. The solvents reservoir can be filled with the varied solvents which have different pH, ionic strength, and polarity. But the important thing about the solvent reservoir is that the solvents must be miscible. That is, जो भी आप solvent लेंगे वो आपस में miscible होने चाहिए. Their miscibility should be high. And second, they should be in a pure form. There should be no impurity present in a solvent. Then one more thing, that they should be properly degassed. That is, they should be properly degassed. It can be done either by through a inert gas, or it can be done by sonication, so that the gas bubbles can be removed, which will if not degassed, they may be result a blockage of the pipes. So coming to the pumping system, so the role of pumps is very evident, that it helps the solvent flow under pressure through the column. So the role of pumps is can be very simple. That इसका जो pumps का जो role है, ये solvent को under pressure जो है column के through pass करता है. So the role of pumps is there are 2 different roles of the pumps that we have to look out. One is that the pumps जो है वो solvent को under pressure flow करते हैं, so that the solvent can move through the packed column. जो आपका कॉलम होता है वो पैक्ड कॉलम होता है, स्मॉल पार्टिकल साइज होता है, so it is very densely packed. Now to flow a solvent through that densely packed column, you have to increase the pressure of a solvent, and that can be done by using the pressure pump. So we have different types of the pressure pump. Second, there is a back pressure because of the strong packing material. There is a back pressure, so it also works against that back pressure. So the role of HPLC is to deliver the solvent and under high pressure, and also to work against that of the back pressure that has been developed because of the strong packing material, which has been very closely packed because of the smaller size and because of the spherical irregularity of the packing material. So the pump जो हमारे पास होते हैं वो तीन तरीके के पंप हम यूज कर सकते हैं. Displacement pumps are there, reciprocating pumps are there, pneumatic pumps are there. So we had three different pumps which can be used in HPLC system. But 90% of the HPLC systems जो हमारे पास हैं वो reciprocating pump जो है use करते हैं. So what is the role of pump? The pumping pressure of the several hundred atmospheres are required to achieve the reasonable flow rate with the packing in a 3 to 10 micrometer particle size range. So this is what I was saying कि पहला काम जो है that it should be able to provide a reasonable flow rate, because जब packing material जो है densely packed है, अगर आप solvent ऊपर डालते हैं तो it is very unlikely that the solvent can move through the column unless and until you provide a pressure. You provide a pressure by using a pressure pump. So the first important thing of the pump is that it provides a several hundred atmospheres that are required to achieve the reasonable flow rate with a packing in a range of 3 to 10 micrometer size, which are common in modern liquid chromatography. So these pumps are common in modern liquid chromatography. As a consequence of these high pressures, now again, as a consequence of these high pressures, the equipment for high performance liquid chromatography tends to be more elaborate and expensive than that encountered in the other types of the chromatography. क्योंकि हमें under high pressure काम करना होता, so its column should be very stable to that pressure, its tubing should be very stable to that pressure. There should be every part that is used in HPLC should bear the pressure, should be stable to that pressure that is provided by the pumping system. So that is why an HPLC system is more elaborate and more costlier than that of the other types of the chromatography. The pump has a role of passing the eluent through the column at a specific flow rate. So the पहला role जो है ये solvent को flow करता है through the column at a reasonable flow rate, because if the pumps are not there and you have a strong packing material of around 3 to 10 micrometer size, it is unlikely that a solvent can pass through the column. So the first role of the pump is that it passes the eluent through the column at a specific flow rate by simply by providing the pressure of around 1200 to 6000 psi, so that you can maintain a specific flow rate. Second, the back pressure result from the improved packing material of HPLC columns has to be countered with the external pressure pump so that they maintain a constant flow rate. So that is what I was explaining to you कि दो चीजें जो है पंप का काम है. पहला ये है कि ये इतना प्रेशर दे देता है एक सॉल्वेंट पे ताकि ये रीजनेबल फ्लो रेट मेंटेन कर सके थ्रू द कॉलम. दूसरा, since we have a strong packing material, strong in a sense that they are very closely packed and particle size is very small, so there is a back pressure of a solvent because of the improved packing material. Now to counter that back pressure, we need a external pressure pump to maintain a flow rate. So this is the role of the pump to maintain the flow rate, constant flow rate of around 1 to 2 ml per minute at a pressure of 100 psi. You need to have a pressure pumps that can help us to achieve a reasonable flow rate through a column by using a pressure pumps. Now pump का काम क्या है? The requirements for a liquid chromatography pumps include पहला, the generation of the pressures up to 600 psi. So you can have a HPLC machine that can work on 1200 psi. You can have a HPLC machine that can work at a 3000 psi. So there's a pressure range up to which you can use. So the maximum pressure that needs to be generated is around 600 psi or 414 bars. The solvent that is flowed through the column should be pulse free. There should be no pulsation in a solvent. It should be able to maintain a flow rate of around 0.2 1 to 10 ml per minute, but the ideal flow rate is around 1 to 2 ml per minute. So it should be able to deliver it at zero point 0.1 to 10 ml per minute. There should be a flow reproducibility of 0.5% relative or better. So reproducibility of the pump should be around 5.5%, or it should be better than that. All the components of the pressure pump should be corrosion resistive. They should be resistant to corrosion. Otherwise, again, the impurities will leak out, or there will be the leakage in the pump. Now, pump जो है वो दो किस्म के हमारे पास होते हैं. One that can deliver a solvent without changing its composition, जिसका composition constant रहता है. So we have an isocratic pump. We can have an isocratic pump, or we can have a gradient pump. Now, isocratic pump is one that delivers the constant mobile phase composition. That means we do not alter the percentage of any components. It starts with 1% and it ends at the same percent. Solvent must be premixed. For example, you are using a solvent of methanol and water for the separation of the polar component. So in isocratic mode, what you have to do is you have to fix the concentration of the water, and you have fixed concentration of the methanol. For example, you start with the 20% of the methanol and 80% of the water. Till the separation is over, it will remain the same. There will be no change in the composition of the solvents. It will remain same at what was it initially and at the end of the separation. So there will be no change in concentration of the any components. You can have more than two solvents. It is not necessarily that isocratic pump means a single solvent system. In isocratic mode, you have the different types of the solvents. You can have 4 different solvents, but they should be either premixed. You have to premix them so that you can get a single solvent system that can be flowed. Then you have a gradient pump. Gradient pump ka kaam jo hai, it can deliver the variable mobile phase composition. That is, there is a possibility of programming. That is, you program your system. For example, again, you start with the methanol and water. For example, methanol initially 80% लेते हैं और water जो है 20% लेते हैं. Now you want to change the polarity of the solvent after a certain time. So you can program it. After 10 minutes, there should be 80 to 60. Then after 20 minutes, it should be 60-40. After again, there should be variation 70-30. So you can vary the polarity of the solvent, and that is the utility of the gradient pump. Now the important thing is that if you are using a gradient HPLC, अगर आपके पास HPLC machine जो है जिसमें आप there is an gradient pump, then the gradient pump can be run on an isocratic mode. But isocratic pump cannot help us to run a gradient mode, because isocratic pump में आप खाली एक concentration लेते हैं जिसको आप premix करते हैं, जिसको आप fix करते हैं और वही चलती रहती है. Gradient pump में आप उसको vary कर सकते हैं. So gradient pump can be used as in isocratic mode as well as in gradient mode. So this is the example where you can easily understand what is isocratic and what is gradient HPLC. Now isocratic में mobile phase solvent composition remains constant with the time. So you have this red line. This is a percentage of a B mobile phase. For example, you have two mobile phases A and B, in which the percentage of the mobile phase, you plot a percentage of the mobile phase with the time. So in isocratic phase, you can see that the concentration of the B remains constant throughout the run. Up to 25 minutes is the run time. So it remains constant up to 25 minutes. But in gradient, you can see that after 5 minutes, it is 20% of the B. And after 10 minutes, it is 30% of the B. After 15 minutes, it is 40%. After 20 minutes, it is 50%. And after 25 minutes, it is 60%. So the variation in the concentration of B in gradient, but there is no variation of the B in isocratic. So isocratic mode is run with a single composition. It can be of different solvents, but the composition, initial concentration will remain same throughout the run. But in gradient mode, the concentration can be changed with the time, because we can run a program and we can fix that after a particular instant of the time, the concentration of the mobile phase should be changed. So isocratic mode is best for the simple separations, often used in a quality control application that support are in close proximity to the manufacturing process. So normally जो isocratic mode है ये बहुत जो simple separation हो जहाँ polarity जो है separation जहाँ polarity काफी different हो, so you can easily separate by using the isocratic mode. But if it's a complex mixture, complex sample जहाँ पे बहुत सारे sample है, then you need a gradient HPLC wherein you can change the solvent composition to bring out the good separation of the individual components. Best for the analysis of the complex samples, often used in method development for unknown mixtures. Linear gradient are most popular. For example, gradient is shown at the right. So you can see there is a variation in the composition of the B in gradient mode, and there is no variation of the B in isocratic mode. So isocratic and gradient means, isocratic means a system in which there is no change in composition of the solvent. There is, and that means we do not alter the percentage of any components, but in gradient delivers the variable mobile phase composition. So this is a basic difference between a gradient and the isocratic mode. But one thing you should remember, that gradient HPLC can be used to run an isocratic mode, but isocratic HPLC cannot be used for the gradient mode. Now you can have the different types of the chromatographies in HPLC. That is, I said that HPLC is not different from the other types of the chromatographic techniques. It uses the same basic principle of the packing material, solvents, processes, mechanism of interaction. Only thing is that here the separation is improved one because of the smaller particle size and because of the pressure pump that we are using for improving the decreasing rather the retention time of a solute molecule. So you can have a HPLC normal phase chromatography in which you use a silica gel, and then the mobile phase will be N-hexane or IPA, that is isopropyl alcohol, and then the process will be the adsorption. So you can use a reverse phase chromatography, that is reverse phase HPLC. In this you have the column, that is C18 column, the silica gel modified by a C18. Then the solvent is methanol and water, and the interaction are hydrophobic. Size exclusion chromatography, you use a porous polymer. Solvent is THF, that is tetrahydrofuran. Then the gel formation interaction. Ion exchange में ion exchange gel होता है और buffer solution आप ले लेते हैं. FTT chromatography में you packed it with a ligand. Then again you use the buffer solution and the interaction is the affinity. So these are the different ways by which HPLC can be carried. So you can have an HPLC in which a packing material can be silica gel. You can have a HPLC in which a packing material can be silica C18. You can have a HPLC in which the packing material can be porous polymer. You can have an HPLC in which a packing material can be ion exchange gel. So you can have a different types of HPLC depending upon the type of the packing materials. So coming to the first pump, that is a reciprocating pump that maintains the constant flow pump. We also call it 90% of the HPLC systems use this pump. Now reciprocating pump, here it is given in detail, you can read that. I will explain the working, how it works like. So in reciprocating pump, you have a motor that is fitted with a piston. So it is fitted with this piston. This is a piston that is fitted with this ball. Now when it rotates, it can have two motions. It can move out of the this cylinder, or it can move into the cylinder by using to and fro motion. Now when it moves out of the cylinder, what happens that the solvent moves into this chamber. ये solvent इस chamber से अंदर आ जाता. So there is a ball value check. So यहाँ पे दो ball values है that checks the reverse direction of the mobile phase. वो वापस mobile phase को जाने नहीं देते हैं. जिस जो direction है उसी direction में mobile phase अंदर आता है, ये back वापस नहीं जा सकता. So when it moves out of this chamber, the mobile phase moves into the chamber, and then it presses the back, that is, it moves back into this chamber. It results in the flow of the solvent through this ball value into the column. Here we have a pulse damper that damps any pulses that has been created by the movement of this reciprocating pump. So you can see here, reciprocating pump usually consists of a small chamber in which the solvent is pumped by back and forth motion of a solvent driven piston. Two ball check values which open and close alternately and control the flow of the solvent in and out of the solvent. So this is how ball check values control the flow of a solvent in only one direction. The pump delivers the solvent by continuously repeated backward and forward motion. In a backward stroke, the solvent is sucked into the pump, and forward stroke, the solvent is delivered into the pump. The pump is provided with a motor and reciprocating piston and a ball chuck values. So this is how it works. दो मोशंस हो सकती है, एक में ये बाहर जाता है तो सॉल्वेंट अंदर आता है, दूसरी मोशन में ये इसको प्रेस करता है सॉल्वेंट को, तो सॉल्वेंट फ्लो हो जाता है थ्रू द कॉलम. सो इट हैज एन मोटर, इट हैज एन पिस्टन. That piston moves to and fro. As a result, the solvent moves into the chamber and then it goes to the column. Now, efficient way. Now, what happens that if it is only with a single piston, then there will be a pause in delivering the solvent. So to remove that pause, what has been done, that there is a dual piston. So we have a dual piston reciprocating pump which have the back and forth motion alternately. The efficient way to provide a constant, almost pulse-free flow is the use of the dual head reciprocating pumps. Both pump chambers are driven by the same motor through a common eccentric cam. This common allows the piston to pump while the other is filling. As a result, two flow profiles overlap with each other, significantly reduce the pulsation of the downstream of the pump. Now, this double reciprocating pump क्या करता है कि ये एक ही पंप से जुड़ा रहता है. So जब एक पंप की, एक पिस्टन की towards the chamber motion होती है, तो at the same time दूसरे की जो है वो against of that होता है. That is, एक पंप पिस्टन के अंदर जाता है, एक पंप चैम्बर के अंदर जा रहा है, दूसरा पंप चैम्बर से बाहर आ रहा है. So at a particular instant of time, one helps to एक इंस्टेंट पे, किसी एक टाइम पे एक पंप जो है वो सॉल्वेंट चैम्बर में डालता है, दूसरे इंस्टेंट पे जब वो पंप बाहर जाता है तो दूसरा पंप जो है वो काम करता है. सो इट प्रोवाइड्स अ सॉल्वेंट व्हिच इज पल्स फ्री, so that there is no lag, there is no pause between the two strokes. अगर यहाँ पे ये एक ही पंप यूज करते हैं तो ये जब बाहर जाएगा तो ये सॉल्वेंट अंदर आएगा. ड्यूरिंग दैट देयर विल बी अ पास. नाउ होता क्या है, जब दो पंप हम यूज करते हैं, जब ये बाहर जाता है तो दूसरा पंप जो है उस टाइम सॉल्वेंट को प्रेस करता है. जब ये अंदर आता है तो वो दूसरा पंप जो है वो सॉल्वेंट को सिलेंडर में खींचता है. सो देयर आर द टू पंप्स दैट वर्क साइमल्टेनियसली विद ईच अदर, so that they can provide a solvent which is pulse free, which can be, there be no time lag, and there will be the two profiles जो होंगे, solvent profile जो है वो overlap होंगे to provide a solvent which is free from the pulsation. So this is the first pump that can be used. Second pump is called as displacement pump or the syringe pump. Now in displacement pump or a syringe pump, you have again a solvent reservoir. Now you have a syringe here. Now this syringe that it is provided with a plunger. Plunger जो काम, जब हम plunger को बाहर लाते हैं तो ये क्या है, solvent, again it takes the solvent into the column. The displacement pumps usually consist of large syringe-like chambers equipped with the plunger, activated by the screw-driven mechanism powered by the stepping motor. Again इसके पास मोटर होता है. इस मोटर की वजह से जो है ये syringe जो है, जैसे आप इंजेक्शन लेते हैं घर पे, तो वो जब हम प्लंजर को बाहर निकालते हैं तो वो सॉल्वेंट सक कर लेता है, और जब हम वापस प्लंजर को बाहर देते हैं तो सॉल्वेंट वो अंडर प्रेशर बाहर वापस डाल देता है. सो द सेम प्रिंसिपल इज वर्किंग इन द डिस्प्लेसमेंट पंप्स. इसमें आपके पास प्लंजर होता है, सो इट टेक्स द सॉल्वेंट व्हेन इट इज मूविंग आउट, एंड देन व्हेन यू प्रेस द प्लंजर बाय यूजिंग अ पंप, it provides the solvent under pressure to the column. The pump provides a pulse free flow which is also independent of the column back pressure and solvent dispersal. But the disadvantage of this pump is that you have a limited capacity of the solvent. जितना plunger में आ जाएगा, जितना उसकी capacity होगी उस displacement pump की, उतना ही solvent उसमें आएगा. So because there is not a continuous flow of the solvent, you have to suck the solvent and then you have to again press this solvent, and the capacity will be only limited that of the capacity of that pump. But it has a limited capacity of 250 ml, and it requires the refilling of the solvent chamber for continual use. The pump can only elute the solutes that have the retention volume equal or less than the pump capacity. Now ये पंप कब यूज कर सकते हैं? फॉर एग्जाम्पल, यू वांट टू elute a component A or you want to elute a component B, and it has a retention volume of around 100 ml. So you can easily use this displacement pump or the syringe type of the pumps, because the volume needed to elute a component from the column is around 100 ml. So you are safe when you are using the displacement pump or a syringe pump which has a capacity of 250 ml. अगर किसी कंपोनेंट की रिटेंशन वॉल्यूम जो है वो ज्यादा है, देन इट इज नॉट एडविजिबल टू यूज अ डिस्प्लेसमेंट पंप. डिस्प्लेसमेंट पंप तब यूज करेंगे हम जब आपके कंपोनेंट जो हैं जो सेपरेट होना चाहते हैं. इफ यू हैव टू डिफरेंट कंपोनेंट्स, फॉर एग्जांपल ए एंड बी, एंड दे हैव द कंबाइंड रिटेंशन वॉल्यूम ऑफ 150 ml or 180 ml, then you can easily use the displacement pumps. Otherwise displacement pump आप यूज नहीं कर सकते हैं जहां पे रिटेंशन वॉल्यूम जो है वो ज्यादा है. Then you have the third type of the pump, that is the pneumatic pumps. The pneumatics is the branch of technology that uses the force of compressor gases to generate the mechanical effect. Now I can explain it here on a diagram. So you have the two. This is a piston, but the difference is that from here, this side the surface area is more. From this side the surface area is less. So when the air flows through this chamber, there is a larger surface area, and this surface area provides then the more pressure, and this pressure is then transferred through this smaller piston on the solvent that is flowing to this chamber. The pumps use the double piston system, with one piston having a substantially larger diameter than the other. The compressed gas from the outside pushes the larger diameter piston, which in turn pushes against the gas or the liquid in an intermediate chamber. This is an intermediate chamber. Because there is no pressure loss between the larger piston and the smaller one, the smaller piston receives a high amplified level of the force, which can translate into the powerful mechanical action. So there is no loss of the pressure between these two pistons. So यहाँ पे जो pressure होगा वो ज़्यादा create होगा, and because we have the larger piston at the top. Now this pressure that has been created can be then used for a powerful mechanical action. In this case, in HPLC system, it is used to create a pressure for drawing the solvent through the column by using this mechanical action of this piston. The third component is very important in the HPLC system, and this is called as a sample injector. Now sample injector जो है, मैंने आपको पहले ही कहा था, there are two types of the sample injection system. I will go back. So this is a manual injection system, जहाँ पे आप manually जो है sample को inject करते हो. Once you have done with one run, then you have to put the next sample, and then you have again to inject the sample through this injector port. But in modern HPLC, which are automatic one, you don't need to have an injector. There's an automatic injector. You need to put your samples in these vials. There are around 160 or 200 vials. You can prepare 200 samples at a time. Then this tray can be put into the sample tray can be put into the place, and then we can program it, and then जो आपका इंजेक्टर होता है, ऑटोमेटिक इंजेक्टर होता है, वो खुद ब खुद इससे इंजेक्शन लेता रहता है. So you can take injections one by one depending upon जो आपने प्रोग्राम किया है. So इंजेक्शन का काम क्या है, इंजेक्टर का काम क्या है, whether it is manual or whether it is automatic. The injector has a role that it places the sample into the loop of a solvent. जो solvent जो है वो कॉलम की तरफ जाता है. अगर हम इंजेक्शन नहीं देंगे तो solvent जो है खाली रन करेगा, sample रन नहीं होगा. So once the sample is run by using the HPLC, then you need an injector which can place your sample into that loop so that it can pass to the column. So normally जो injector हमारे पास है, the sample injector is used to introduce the sample into the column under high pressure. A common injector that is used is Rheodyne model 7725. This is one of the model of the injector that is being used in an HPLC system. Now this injector consists of 6 port values with a rotor. This is 6 port values 1, 2, 3, 4, 5, 6, or here you can say 1, 2, 3, 4, 5, 6. So it is provided the 6 port with a rotor. ये आपका rotor है जो rotate होता है. It is not fixed one, it is rotatable. You can rotate this rotor. Then it has a needle through which injection can be done, and it has a sample loop. ये इसकी pipe होती है जिसको हम sample loop कहते हैं. So this is an injection system through which a sample can be loaded into the column. In loading position, अब इसमें दो positions होते हैं. I will not go by the text. I will go explain it on you the figure. Just a minute. So this is a sample injection system. This is an injector. That is a 6-port system injector. Now I can explain here it on this diagram. So there are two positions. One is the load position and one is the run position. What you do in a load position, that you rotate this rotor. You rotate this rotor in such a way that this becomes a separate part. Column and the pump becomes a separate part. So the solvent is only flowing through the through this injector port and then into the column. There is no sample. At this point of time, you can inject the sample. This injection goes into the sample loop. This is a sample loop. So this in green is a sample filled. So आपने इसको sample fill किया, ये इस loop में चला गया. So it is a separate entity. ये जो है ये separate. So this is a load position जहाँ पे आप sample जो है load कर रहे हैं. आप रन नहीं करें, खाली सैंपल को लोड करें. आपने सैंपल डाला, वो सैंपल लूप में चला गया एंड इट जो एक्स्ट्रा है वो वेस्ट में चला गया, वो बाहर आ रहा. और ये लूप जो है फिल्ड विद द सैंपल है इसमें. एंड देयर इज अ सेपरेट सिस्टम दैट इज रनिंग, दैट इज पंप एंड द कॉलम. सॉल्वेंट पंप से आ रहा है, वो कॉलम के थ्रू बाहर जा रहा है. नाउ दिस इज अ लोड पोजीशन. नाउ इन रन पोजीशन यू रोटेट दिस रोटर. आपने इस रोटर को फिर से रोटेट किया. सो व्हेन यू रोटेट दिस रोटर, व्हाट हैपेंस दैट the column sample loop जो है that becomes the part of the system. जो पहले separate थी, इस position में ये sample loop जो है separate है, but when you rotate this, it becomes the part of this system. When it becomes the part of the system, now the solvent move from the pump, then through the sample loop and then to the column. Earlier, what was happening? The solvent was moving through the pump and then directly to the column. There was no sample loop. But when you rotate now this injector port, it becomes the part of a system, and then the sample moves into the stream of a solvent. So this is how it actually happens. In loading position, a sample is loaded in the sample loop by switching the value in the injection mode. Then the rotor is rotated and the sample loop becomes the part of a solvent system, and the sample moves into the solvent and then into the column. Two of the ports are connected by an external sample loop of known or fixed volume. In one configuration, known permits the direct flow of element into the column. एक कॉन्फ़िगरेशन में जो है आपका पंप और कॉलम आता है, जहां पे सॉल्वेंट जो है खाली पंप के थ्रू जाता है और फिर कॉलम में आता है. So in one configuration, the cone permits the direct flow of the element into the column and the sample loop can be filled with a sample. और इस पोजीशन में हमें सैंपल को लोड करना. इन द नेक्स्ट कॉन्फ़िगरेशन व्हेन वी रोटेट इट एट 30 डिग्री सेंटीग्रेड, जब हम इस इंजेक्शन पोर्ट को रोटेट करते हैं, सैंपल लूप जो है दैट बिकम्स द पार्ट ऑफ मूविंग एफ्लुएंट व्हिच स्वीप्स द सैंपल इनटू द कॉलम. दूसरी कंडीशन में जब हम इसको रोटेट करते हैं, नाउ दिस सैंपल लूप दैट वाज अर्लियर separate entity, it becomes the part of the system and then the sample is moved into the stream of a solvent. So this is how the injection system works. Normally you have an injection system like this. So you have a syringe, you take the sample and then you pass through this injection in manual system. आपने इसको inject किया, उसके बाद इसको rotate किया and it becomes closed. उसके बाद आप अपना run चालू कर सकते हैं. So this is the role of an injection system.